This video is going to review distribution and foiling. The first topic to review is the distributive property. The distributive property lets us multiply something inside parentheses by something outside parentheses. And we do this by multiplying individually each of the terms inside parentheses. It's a little easier to just see an example. So I'm going to take my A and multiply it with B. So I have A times B. And then I have to take A and multiply it with C. And I'm going to add those two products together because I have this addition sign in the center. So let's do another example. Here I have a negative 6 outside, so I'm going to multiply that with my x. So I'll have negative 6x. And then I'll take my negative 6 and I'll multiply it with negative 8. And negative times negative becomes a positive 48. Let's look now at a slightly more complicated example. I now have a trinomial inside my parentheses, but it works exactly the same way. I'll take the 3x, which is outside the parentheses, and multiply it with 2xy. So 3 times 2 gives me 6. X times x will give me x squared, and then I still have my y. Then 3x times negative 7x squared. That's going to be a negative 21x to the third. 3x times 1, that'll just be plus 3x. So it really works exactly the same way. Now things get a little more complicated when I have two sets of parentheses. So I now have a binomial and another binomial multiplied together. It's really the same idea though. I'm going to take this whole thing out here, multiply it with that, and then this whole thing out here again, the x plus 3, and multiply it with my negative 4. So let's see that go now. I'll have x plus 3 times x, and then plus x plus 3 times negative 4. So now I actually, if you can sort of see this, I'm going to be doing the distributive property again, though now from the other side. So x times x will be x squared, then x times 3, x plus 3x. And then I'm going to have a minus 4x and a minus 12. Notice these two terms have the same variable, the x, and the same exponent, so I can actually combine them. So x squared plus 3 minus 1 minus x minus 12. Now you might be thinking that last example was a little confusing and maybe a little complicated. We had to distribute from the right back to the left, which we're really not used to doing. And it would be pretty easy to make mistakes like dropping this negative sign over here. So we have this acronym called FOIL that actually simplifies the process. So let's look at that now. All right, so here I have another example where I have two sets of parentheses, so two binomials that I'm trying to multiply together. We're going to use this idea of FOIL, which is really just an acronym that makes sure that we catch all the terms, that we multiply every term with every other term. So FOIL stands for first, outer, inner, and last. So I'm going to start by multiplying the first term of each binomial. So the first term on the left is x, first term on the right is also x, so I have x squared. And then I'll take the outer of each binomial. So let me change my color. Outer is going to be x again on the left and negative 7 on the right, so minus 7x. For outer, I like to think of like the bread of a sandwich, which then makes the inner this 2 and this x, so I have plus 2x. So I've done first, outer, inner. Now I'm on to my last, and my lasts are going to be the last term in each binomial. So I have my 2 and my negative 7, so minus 14. Now notice these two terms in the middle here are what we call like terms, so I can combine them. So I'll have x squared minus 7x plus 2x, that will give me a negative 5x, minus 14. And we're done. Let's look at another example here. So now it's a little more complicated. I have coefficients on my x terms, but it's going to work the same way. So I'll start by multiplying my first term. So 2x times 4x will give me 8x squared. And then I will multiply my outer terms. So 2x times y is 2xy. And now I will do my inner terms. So that will be minus 4xy. And my last terms, minus y squared. Now, let's see if we have any like terms. It looks like the two middle terms both have xy's. So I can do 8x squared plus 2xy minus 4xy is going to give me negative 2xy, then minus y squared. And we're done. This next example is going to demonstrate why FOILing is really so important. Looking at this problem, x squared minus 8, it's extremely tempting to just want to put that squared on both the x and the negative 8. So to say x squared minus 64. But if you do that, you're not going to get the right answer. This is incorrect. We really need to think of this as a FOILing problem. So x minus 8 times x minus 8. Because that square just means multiply this thing, whatever's squared, by itself. And now I am going to FOIL. So I will do x times x squared, x times negative 8 minus 8x, negative 8 times x minus 8x again, and negative 8 times negative 8 is going to be a positive 64. Combine my middle terms, I get x squared minus 16x plus 64. So notice, if you had done this incorrect way, you were missing this negative 16x in the middle. So you would not have gotten the right answer. So you always want to think of FOILing when you see a binomial squared. Okay, here's a slightly more complicated example, and we're actually not going to be able to use the first, outer, inner, last method anymore, but we can use that same idea with those arrows that I've been drawing. We're going to take this x, which is the first term in this first binomial, and multiply it with each of the terms of the second polynomial, which is actually a trinomial. So I'll do x times x squared, and I will get x to the third. And then I'll do x times negative 2x, and I'll have negative 2x squared. X times 10 plus 10x. Now I'm about halfway done. I'm now going to take my 3 and multiply it also with each of the terms in that trinomial. So plus 3x squared minus 6x plus 30. Now I can go through and look for some like terms. It looks like this negative 2x squared is like my 3x squared, and my 10x is like my negative 6x. So I'll combine some like terms. So x to the third had nothing similar, but negative 2x squared and 3x will give me a positive x squared. And then positive 10x minus 6x is going to give me plus 4x. And then I still have my plus 30 from the end right there. And that was from right there. All right, just one last example that often confuses people is, what do you do when you have 3 binomials to multiply together? Well, you just have to FOIL twice. There's no way around it. So pick 2 of them, FOIL them together, and then multiply it by the third. So I, just for fun, am going to pick these last 2, and I'm just going to start with those 2. So I'm going to do x times 6x, so 6x squared, and then x times 1. And then 2 times 6x, and 2 times 1. Combine my middle terms, so I have 6x squared plus 13x plus 2. But remember, that's only 2 of them multiplied together. So I'll stick those in parentheses, and then I'm going to bring down this one that I did not include in my first multiplication. And now you can see why that last example was really so important, because we now have a binomial times a trinomial. So I'll start with 4x and multiply it with, in turn, each of the terms of the trinomial. So 4x times 6x squared gives me 24x to the third. 4x times 13x is 52x squared. And then I'll do 4x times 2, so that would give me 8x. And now I'll take my -3 and multiply it with each of these, being very careful of my negative signs. So -3 times 6x squared, -18x squared. -3 times 13x, -39x. -3 times 2 is -6. All right, let's find some like terms. I have a 52x squared and a -18x squared. I also have an 8x and a -39x. So I'm going to start by writing down my 24x to the third, just because we traditionally put the largest exponent first. And then I'll do my x squareds, which is 52x squared minus 18x squared, which is going to give me 34, x squared. And then 8x minus 39x is a -31x. And then I'll just tack on my -6 at the end, and we're done.